Hello everyone, welcome to Excel Maths. This is question number 4 from mock set 5 mechanics. So as we can see, there is a particle P on the slope and the mass of particle P is m. And this slope is inclined at an angle alpha and we know tan alpha. So if tan alpha is this, we can find out sine alpha. Give me a sec. Okay, so if we have tan alpha given to us, that is 3/4. If we just draw a triangle, if this is alpha, opposite and adjacent, we can find out your hypotenuse is going to be 5. So can we find out sine alpha from here? That means 3/5, and cos alpha is going to be 4/5. So let's write sine alpha, that's 3/5, and cos alpha is going to be 4/5. That makes sense. Now what we need to find out, the particle P is projected with the speed of u up the line of greatest slope. Is projected up the line of greatest slope of the plane as shown over here. The coefficient of friction is given to us, mu is given to us, air resistance is negligible. We have to show that as P moves up the plane, the deceleration, that means it is projected, you pushed it, it's going to be moving up, and at some point it is decelerating, that means speed is decreasing, and at some point it will stop. This is something like that I'm able to understand from this context. Okay, so we have to show that its deceleration is 31/25 g. What we're going to be doing, we are going to be drawing the all the components. So as I told you earlier, we just are going to be using the plus here. So let's use our plus and try drawing the components. So the first one is going to be like this, and the other one would be like this. I need to move it down like this. Perfect. So this is the plus we have. One more we need to draw for the weight. The weight is always perpendicular to the surface, this horizontal surface. So this is what we have to draw every time whenever we are resolving components. Okay, so this is W, this is W, that is equal to mg. This angle is alpha, so this will also be alpha. So this will be mg cos alpha, and just 90 degree to this one, that means this side is mg sin alpha. Correct? And the top is R. R is normal reaction. Okay, now what we have, because it's going up to the greatest slope, that means we definitely have friction over there, and it is decelerating. Friction, what the direction of friction will be? Can you think of? It is going up. When you pushed it, is going up and it's decelerating. That means continuously we are getting a force applied this side, which is the frictional force, right? And we also know the coefficient of friction. Okay, now we are going to be using the force of motion, F equals ma. F equals ma. So as you can see, we are having both the forces, like frictional force as well as this component of the force, component of weight going downwards. So we are going to be adding, and the object is moving upwards the slope. So we are going to be writing minus mg sine alpha minus frictional force. So frictional force F, how should I write F? These two, this is force and this is frictional force. That is equal to M and A. So before this, let's quickly find out, because we have frictional force given to us, if we resolve these forces, the force perpendicular to the slope, so it's going to be resolving these forces. So we are going to be getting R is equal to mg cos alpha. So cos alpha is 4/5, so R is actually 4/5 of mg. When we talk about this frictional force, so F is equal to mu R. So we need R, that is why we just resolved it, we solved it first. So R is, mu is 4/5 of R, which is again 4/5 of mg. That's giving us 16/25 of mg. Okay, now let's substitute all the values. Sin alpha is 3/5, so minus 3/5 of mg minus 16/25 of mg, that is equal to ma. We can divide by m, so we're going to be getting minus 3/5 of m, I mean not m, just g, minus 16/25 of g, that is equal to a. Okay, if we simplify this, so just multiply by 5 and 5, so it will give you minus 15/25g minus 16/25g, that is equal to a. So your acceleration comes minus 15 minus 16 minus 31/25g. As it's negative, so we can say it is decelerating with 31/25g meters per second squared, right? So this is what the deceleration is, and we've got the same thing. A negative shows that it is decelerating, correct? So the A part for 6 marks, I mean, in real exams, this was easy, 100%. In real exams, you won't be getting easier like this, or you may. But I didn't find this mock set to be very hard, truly speaking. Now for the B part, what we need to do, find the particle comes to rest at point B on the plane. Okay, so say for example, it reaches here and this is point B. At point B, it comes at rest. See, it is the slope. But if it is coming at rest, that means there is a greater frictional force acting. I mean, the force of friction is very strong. Now, just imagine yourself to be bicycling, or you are over there and bicycling obviously, and if you are standing over there, that means someone is actually holding you, this is your friend and is actually holding you, otherwise you will start moving backwards. So if this object is staying over there, that means it is getting holded by a force, and this is the frictional force obviously. So the direction of the frictional force is this direction. If it is it is F max, frictional force. And now what is the force opposite to this? It would be this mg sin alpha. It would be working opposite to that, mg sin alpha. Rest we need not to really show over here, because what it is asking us, we have to find AB. From point A to B, we have to find out the distance. We are going to be thinking of Suvat conditions. So V equals U plus AT needs time. Second, S equals UT plus half AT squared also needs time. The third one is going to be working, that is V squared is equal to U squared plus 2AS. Okay, acceleration we already found there. That was deceleration basically, but we found. And now what it says, it comes to rest. That means V is 0. You would be understanding V is 0. So we are going to be writing 0, which is equal to U is given to U. That is cool. So 2GD squared plus 2. Acceleration is minus 31/25g. And outside you have S, and S is nothing but the distance AB we have to find out. Okay, so here we're going to be writing 0, which is equal to 2GD minus 61/25GS. If we move it there, we're going to be getting 61/25GS, that is equal to 2GD. We're going to be dividing by the left side thing. So you're going to be getting 2GD over 61 over 25 G only. Okay, so if we cancel this out, we're going to be getting 2D times 25 over 61. That would be giving you 25 over, did I make a mistake? It was not 61 basically, it was 62. Okay, let me correct that. It was 62 here, 62 there also, and 62. 2 times 31 gives us 62. That will give us 31D. So overall, S is going to be 25 over 31D. And this is our final answer for B part. Given that P remains at rest, P is staying over there at rest. Okay, nice. So if P is staying over there, find in terms of M and G the magnitude of frictional force. Okay, so P is staying where P has gone. Here, P is staying at rest. That means frictional force is going to be holded by mg sine alpha. So P is at rest. Here we have C part. We are going to be resolving these forces. Resolving these forces along, parallel to the slope. So we are going to be getting F max, which is equal to mg sine alpha. We already found the value of sine alpha, which was 3/5, right? So 3/5 of mg. So this is the frictional force which is actually acting over there. And in terms of for 2 marks only, we have to find out the magnitude of frictional force acting at that point in terms of M and G. So this is your final answer. Hope that makes sense. Thank you. Bye-bye. Take care.